Start recording. Okay, great. So today I'll be giving you a brief introduction to kind of what goes into an Arduino board, like the thing that you're going to be using for most of your stuff, and maybe a few other really simple things regarding electronics. So y'all can see the screen very clearly. Okay. Oh, also, if you need any help, you can ask your J2 seniors. They all know roughly what's going on, and they should be able to help you lah. And if they don't know, just ask me. Right. So I'm gonna throw a bunch of very, very big words at you guys, and then you guys don't need to fully memorize them, but let me explain what's going on. So we have this thing called a microprocessor. Whoa, microprocessor. Think about it. It's two different parts, micro and processor. Micro being small, processor meaning it takes something in, gives out something. So this microprocessor is the brain of any computer system, such as CPU. So it's like the thing that does all of the calculations and math within your computer itself for all of the different functions to run in a second. The CPU is a central processing unit and it's just the chip responsible for doing all the calculations. It requires RAM and ROM to function, which is random access memory, and I'm not exactly sure what ROM stands for, but it's not that big of a deal. And yes, any computer system or cognitive function requires the use of microprocessors, like reading articles, playing games, scrolling reels, whatever. Shikai, a bit noisy, yeah? Yeah, flying. Okay. Now, you may have heard this other word I've thrown around quite a lot so far, which is microcontroller. What? Microprocessor, microcontroller. Sounds very similar, right? What exactly is the difference? A microcontroller is an integrated chip that's basically a tiny computer on its own. So you know how I told you a CPU or a microprocessor is part of a computer? This can refer to a computer itself. Right. So there are a lot of different applications of microcontrollers. Like literally any robotic system uses a microcontroller to function. And yeah, the power requirements for these are very, very, very low. And you can run them on batteries for months. They have all the needed memory and storage built onto the same chip. So you can think of like a regular computer lah. Right. So microcontrollers and processors, again, controllers are just cheaper and a controller can't do what a processor does. However, controllers are faster than the human brain and microprocessors are even faster than that, assuming they're from the same generation. Okay, so Arduino Uno, is it a microcontroller or a microprocessor? What do y'all think? Microcontroller. How many of y'all say microprocessor? How many of y'all say microcontroller? Wow, what is this group thing? You guys are right. It is actually a microcontroller. Can anyone tell me why? Before I move on to the next slide. Any idea? What?
I assume it's because it's able to control motors.
Sure. It is. You could say that actually. Yes, it is because it has the ability to control itself. So the microprocessor, like I told you, it's just you feed signals into it, it throws out signals. But this allows you to do specific control of specific systems. And also because, like I said, it has its own RAM and other things that allow it to run. It's basically a computer lah. So yeah, it's kind of a microcontroller. The Arduino board definitely is not a microprocessor. Definitely not, it's definitely not. But it contains a microcontroller called the ATmega328. Yeah. This is basically what's on the Arduino itself, which I'll show you later, which effectively allows it to do all of the different things it does. Yeah. And I know the slides are being grey, white, black, quite boring. Later on you'll see a lot of illustrated images and that'll be quite cool. And later on I'll be doing a lot of interactive stuff with you lah. So yeah, for electronics we'll be primarily using the ATmega328. Okay, open sourcing. Here's another very important principle I'll be talking about quite a lot. Okay. Arduino software and hardware is completely open source, which means they give everything away for free. Everything is you can just find on the internet lah, so it's quite nice, I think. This makes it beginner friendly, and it also means a lot of companies can take the tech that they use and repurpose it for their own purposes.
Call me back. I go practice.
I won't take that long.
Really?
I really won't take that long.
Okay. But
I'll just no, not really.
okay, then when you're done, I go V2 practice.
V2 can huh? Wow, you crazy, yeah. Okay, so Shikai will be practicing his drone stuff. I'll be just teaching you guys this. So yeah, okay, simplification and why our puny little brains can understand Arduino. So robots used to be coded using assembly, which was really, really arduous and tedious processes. So right, the thing is, this is assembly. What you're doing is you're looking straight into the computer, looking at specific certain bits and telling the bits, hey, take this piece of memory, move it somewhere else. Take this data, move it here. You're telling the information where to go, and that's quite crazy lah. For computer programmers, none of us do this unless we are taking a robotics class or we just hate ourselves. Don't worry, y'all won't have to learn assembly. I hope. So yeah, Arduino makes all of this really simple because it takes all of the weird stuff that's going on here and condenses it into very, very clean and beautiful C++. And sometimes Python, depending on whatever versions you're using. Right, here's where I get into the more technical stuff. Board anatomy. This diagram is going to be plastered all around the next few slides, and I'll be explaining every single thing that you can see over here in a bit of detail. First, the digital pin set. So the digital pin set is numbered 0 to 13. Okay, 0 to 13. It's the things over here, right? And this, okay, I'll explain what the tilde is later, but this takes digital input from the sensors and gives output to some components. So right, in electronics, there are two very simple classifications of things. Does it give the board info or does it take out info? Let's look at, for example, a motor. What do you guys think? Does it give in info or take out info? Take out. Why?
It's controlled by things.
Exactly, it's controlled by the board itself. So the board throws electricity at it and says, hey, now you do this thing. You go this direction, you do whatever. Right? So it makes sense? Okay, great. So this digital pin set up here is for input, which means sensors give in data. For example, humidity, I don't know, like water levels, buttons, anything that's input goes into here, right? And tilde means that there's pulse width modulation capability. I'll explain pulse width modulation right after this. But for now, all you need to know is that it controls kind of the power level, right? It controls the power level given to whatever. Okay, so okay, built-in LED. Right, so a built-in LED is auto connected to pin 13. So if you don't put anything at pin 13, it kind of, and you access pin 13, it will just light the thing up. It's kind of an LED lah, so I mean, it's just an LED. Then yeah, a power LED. Okay, this one, it's over here, and it being on means that the Arduino board is active. And if you're using other boards like the Leonardo or the Mega, then you will see that it has different light colors meaning different things. But for now, you just need to know if it's on, it's plugged in. Okay, remember what I told you about the microcontroller that's inside the Arduino? Well, that is your fourth thing, which is the Add Mega 328. This controls all of the main functions of the board. You can think of this as like where most of the stuff goes on, right? And this does all the calculations, and yeah, if you remember what a microcontroller is, then great. It is basically that. So as you can tell, right, your whole board itself is not your microcontroller. Your microcontroller is just a tiny, teeny bit over there. Okay, now, these pins, right, you can connect any analog sensor to all of these pins. Again, same thing I told you before. It's just input and output. And okay, the cool thing about the Arduino is that there are two different kind of sources of electricity you can think about. One is 3.3 volts and one is 5 volts. Why do you think both are given? Does anyone know? I mean, logically, right? Why do you think both are given?
Some components require more power than others, and some will blow up if you put too much.
Precisely. Exactly. It is just a case of how much electricity you need to use in your circuit. Yeah, because sometimes using too much will make it very unsafe for other components. Okay, power pins. Again, y'all don't need to memorize any of this. I'll send you these slides. Power pins. Okay, so the power pins, right, where is it? Yes. Whenever you do any circuit at this level, it's going to be starting from here, so the electricity comes up, and everything will go back to ground. Ground is kind of where it feeds back into the circuit and creates a closed loop. Yeah. So you can technically stick a light bulb or an LED just into 5 volt and ground, just like force it in without any breadboard or anything or any wires. And it should be able to light up by right. It will probably explode though, I'm just saying. Okay, yeah, okay. Ensure your components do not draw a lot of current. Why? Overheats, okay, not a bad answer. Short circuit, not a bad answer. Any other guesses?
Takes power away from the board.
Sorry?
Takes power away from the board.
Takes power away from the... Okay, interesting answer. How do we know? How do we prevent this actually? Well, physics. Remember your V equals IR, I equals V over R. This is the only formula you're ever going to need for Elax. Like, we don't care kind of about how good your physics is. Just know this thing, which is you can't really have a R value of 0, right? If R equals 0, short circuit can occur because of this formula. And the way you remember it is that you can't divide by 0. That's how you generally would remember it. And if V is like stupidly low and R is really, really high, no current's gonna make through. Think about it. Come by the other entrance lah, what? Breaking the door. Okay, so if you remember right, okay, I'll skim through this part very, very fast because like I know y'all probably tired of physics already. I'm also tired of physics too. But your V is just work done to drive a charge, right? So if that work done or amount of energy you have is really, really low, then obviously current won't make it through the circuit lah. You won't power anything up. And if it's the other way around, V is stupidly high and R is really low, too much current will pass through, and then P equals IV, you can blow stuff up. Yeah, it's quite cool. So do the math and ensure you don't blow up the robotics lab. Generally, this is the only formula you need to care about for Elax. But if you're gonna wire anything up, just ensure that you're careful. Okay, back to the start. Power DC jack. Wow, you may be wondering, isn't it you just connect over here and everything, wow, got electricity? No, not exactly. Technically, right, you can connect your Arduino to a DC jack and it accepts 7 to 12 volts. Right? Great. Okay, so again, it can handle that much voltage. Yeah. Okay, TX and RX. This part you guys need to pay attention. Right, so TX and RX are just transmission and reception, which means if your Arduino wants to talk to another board, or maybe to a PC, or maybe to internet, whatever you have it ready for, it should be able to. And RX and TX just tells you whether it's receiving or throwing out information. Yeah. And whichever one is blinking kind of indicates which one it is, right? Right, USB port. Now, this is kind of the big deal. This thing, you can connect straight to your computer and it kind of brings everything to life and it... Okay, you need to ensure that the cable you're using is obviously a data transfer cable. You can't just have a charging cable and expect everything to work. Yeah, okay, one more thing. If you use other boards, the wires you have to use are completely different. For example, if you had to use a Leonardo, right? You would have to use a micro USB one. In fact, I don't think anything uses USB-C. It should mostly be micro USB and whatever this is. Okay, last one, reset button. Okay, this one be very careful with because depending on the board you use, the reset button might end up messing everything up. So, I created a project a very long time ago on the Leonardo, which was basically a thing where I'll plug in into a computer, right? And then, wait, are you familiar with what a rubber ducky is? Yeah, you plug it into a computer, it types commands into command prompt, and then it just executes the commands, takes out information, closes the shell, and yeah. So it was the one that I created was basically to steal the passwords of every single Wi-Fi network the computer is connected to in the last, I think 20 or so connections. It was quite cool. I can show you a video of it later. But the issue with this is that when I hit the reset button, it messed with the memory because it didn't fully and successfully delete all the stuff on it. By right, the reset button just clears the code. But if it doesn't work properly, you're going to end up with issues. Because now when I connect it to my computer, sometimes the code will run, sometimes part of it will run, sometimes it will be slow. It's quite a mess. Okay, here are a few technical specs. Again, you don't actually need to care about any of this. I'm just going to send it to you. So what is most of that? Do we really need to know? Okay, before we get to Shikai's portion, I need to call him. And No, we don't actually need to know most of the stuff by heart. But it's important to understand the main principles. So for example, just be careful with the electricity, know what your different components are, know what each thing on the board does. Okay, now if you want, I can... Don't try. Ashton, please. You damn funny. Okay, so let me give you an example of what a circuit kind of does, right? Let's look at something simple. Let's look at, for example, a simple light bulb circuit or LED circuit, right? Over here. What is going on? Okay, can you all see my the diagram kind of? Can you see what's going on? Right. So just to elaborate, this thing connects into this, powers the thing up. This thing throws out this thing basically throws out your current from here, right? Resistor goes to the bulb, connects to ground. So it's a full circuit, it's a closed circuit, and depending on what the code does, right, it can potentially cause the bulb to do different things. Let me explain. So, okay, before we start, why is there a resistor there? Why?
So that your current doesn't get too high.
Exactly. So basically so you don't blow shit up, right? So let me show you an example of what the code actually does. We're not gonna look at blocks. We're not gonna look at blocks. Let's look at the C++ implementation. So right, this looks very scary. Let me explain to you the very simple principles that go behind this. I know it's gonna look very scary. I'm gonna make it very easy for you guys. Just ignore all of the comments. And I will explain. Okay, great. So this code, very simple. Void setup just means when the thing starts up, do it once and never again. Void loop, however, means after the setup is completed, continuously keep on doing this forever until something happens. Either the board shuts down or there's a stack overflow. Okay? Right, so what happens here? What is going on? What do you think is going on? Okay, I'll explain first. Here, when we say pin mode, whatever output, right? We're saying, wait, let me see if there's any declarations. Where is it? Okay. Generally, right, for pin mode, we would have the number, right? And then the amount of electricity we want to put into it. You can ignore this. This line is just to set things up. You can copy paste it wherever you want. So this just says, okay, at port 13, which is your LED built-in, there exists a thing we can use, right? Roughly make sense? Are y'all with me or are y'all like dead? Kind of that? Okay. Then void loop. Effectively what it says is, digital right, LED built-in, high. So right, there are two states that you can throw to this kind of output in a sense. High and low. If it's high, it will light up, and if it's low, it won't. Delay is just sleep for like one second. So this just says, make the bulb grow, or basically throw out electricity. Wait a second. Let the bulb not grow, or basically reduce electricity, and wait a second again. And don't be fooled up. Low generally means less, right? But here it should mean no. It's just that they wanted to find the opposite word to high, and this is the best alternative they could get. Get it? Right. So if we run this code, what's gonna happen? What do y'all think? It's gonna blink. Right. So if I initialize this, run, it's gonna go on and then off and then on and then off. So that's good. We've run our first circuit on the Arduino. And yeah, okay. Let me see. Log in. Okay, and you may be wondering, right? Okay, let's look at this from another perspective. Over here, why do you think I can only use high and low? If you remember a very small thing I said earlier. Why is it over here I can only use high and low?
Oh, there's no pulse with.
There's no, sorry?
There's no pulse with modulation.
Pulse with modulation, exactly. So over here it says digital PWM tilde, right? Basically, this thing has no pulse with modulation. What that means is you can't just tell the circuit, hey, give me this much electricity, give me another amount of electricity. you need a way to modify it. And for that, I'll get to that in a second. Hold on. There's a slide in my motor drivers presentation that basically explains PWM. Where is it? Where is it? Pulse width modulation. Ah, okay, got it. Great. So, the magic of PWM. Basically, right? Yeah. So basically, right, your PWM. How do I put this? It's not just throwing electricity at something. It's basically throwing a standard amount of electricity for different durations. Yeah. A duty cycle is kind of one whole, I guess you could say, wavelength of the wave. And then after that, the amount of it that's spent at 5 volts and the amount that's spent at 0 volts is what determines how much power your machine gives out to whatever. So let's say we have a motor. If I connected it to something that didn't have PWM, it would have one speed it can go at, which is high, and the other speed is just low, which is not moving up, and that is quite annoying. So how we change this is using a PWM cycle. Basically, if it's at 0%, it will stay at 0 the whole time. It's at 25%. For 1/4 of the duration that it's active, it will be at 5 volts, and for the other 3/4, it will be at 0 volts. And 50%, 75%, 100%, again, it's the same principle. At 100%, it's going to remain at 5 volts the whole time. Yeah. That is effectively what you need to know for PWM. So, right, let me see. I need to investigate if the code for this is this. Also, if you're newer to coding, yes. Yeah, go ahead. Yeah, if you are newer to coding, you can use the blocks on the simulator first. Wait. Okay, it's using a server.h module. Never mind, I don't want to cover that now. Okay, yeah. For now, that is generally what I'll be going through. I'll wait for Shikai to come back first. Please do try to bring your laptops for like next session, because then we can do more interactive stuff. I don't generally like lecturing either. It feels damn weird. /PLD, yeah. Anything that can connect to the internet, honestly. That's not a phone. Yeah. Okay, I'll just call Shikai first, and then I'll wait. Yeah, he asked me to call him. Yeah. Okay, y'all just like take a 5-minute break while Shikai's coming. Oh, Shikai's here. Yeah.
Raka's trying to call you. Raka's trying to call you.
Okay. I had a feeling.
I gave him a damn boring lesson. It's your turn.
Sure.
Because it's theory, right? Who wants to do theory? Goddamn.
You.
No. Have fun.
Hi guys. So, okay. You might think that drones and electronics are not the same at all, but that's not the case. Because we can actually integrate electronics in the drones. You might wonder how. So, do you think we can use Arduinos in drones? Okay, scan this QR code. Let's do a word map. It's a Mentimeter. Alright, you guys can start cooking. Sorry, guys, give me a second. Or I do something. Where is it? I ate. My goodness. How did that come about? That's horrifying. That's very horrifying. Guys, you need to know he's taken, okay? He's taken by our vice president, okay? Dylan, so.
He's doing it.
Huh? No, he's not. Yeah, it's just funny. Oh, sure. Okay, a second. It's just a Mentimeter. No, just scan from here. Okay, I'll just give it like 1-2 more minutes, then we'll start reviewing what we have on the board here. Okay, so let's look at what we have, right? So I see.
What am I looking at?
What
is going on?
I don't know. He's very much taken by another guy. So, anyways, okay. So we have a few responses here. What I think is good is that we have ESC, so which are known as electronic stick controllers. That's a vital component of drones. We have programming drones, building autonomous drones, controller, fly. All very key concepts of what we'll be discussing today. Okay, so that's quite cool. Alright, moving on. Okay, so drone. In drones, there's two things we need to do. We need to build the drone itself, which is building like this outer structure of the drone, and then from there, we have to make it fly somehow, right? Because without electronics, it will just be a glider. And while you glide, that's all it does. That's where electronics come in. It allows your plane to go onward without having to just simply rely on gliding. Okay, so this is what it kind of looks like. Moving on, before we talk about what's inside the drone, let's discuss a few movements of the drone, which is roll, yaw, and pitch. Okay, this is roll. Essentially, your servo motors are connected to the ailerons, and it will adjust the aileron so it allows the plane to roll to the left or to the right. Yeah, so that's roll. For yaw, servo motors are connected to the rudder, and then basically just turns your plane like that. It's a top-down view. Next, we have pitch. So normally what we use pitch for, right, is that in order to move forward, we should have the drone pitching a certain way, and then, well, that controls how you want the drone to go. So that's all your simple stuff. Moving on is electronics. So just now I asked the question, can electronics be integrated into drones? Yes, of course. In the past, we used to go for a competition, a category known as D1, where we actually collaborate with other specs to create this big drone. And inside this big drone, of course, we have to program it since it's much more complicated than what we have. In a normal fixed wing drone, like like this, it merely relies on signals, which is received through the radio receiver on the plane, which is transmitted from the controller itself. So it's very basic lah. Whatever you control the controller is just like that lor. But for bigger drones, you can actually program it and ensure that it's other functions. So as you can see that we have the Arduino board, pilot board, and we have many other components, electronic components. So a few basic components are your ESC, your battery, we can call it the brushless DC motor, and your radio receiver, which is not this picture. Okay, so now I'll slowly go through what they do. So your battery, of course, is your power source. Your electronic speed controller. So what this does is essentially it takes signals received by the radio receiver and kind of like translates it into movements for your motor or your servo motor, etc. etc. And your brushless DC motor receives signals from your ESC, which allows it to turn. Yeah. And the rest you want to continue?
Oh no, I already told you I'm done. I can't do anything else anymore.
Oh, this is done.
Yeah, I was doing a theory lessons.
Okay, wait. I got my quiz. See? Done?
Escape, yeah.
Oh, done?
Yeah, there's nothing to teach. No, I literally can't teach anything. What?
Okay. So let's have okay, let's have a quiz then. Just scan another QR code.
Yeah, your connection is dying.
Okay.
No, it's not.
I know. It's dying. But all they need to do is scan the QR code.
I thought Kahoot.
Brother, Kahoot need the premium. Only 3 people can do. So I change it to a quizzes. Wait,
Guys, please do bring your laptops next time.
also I can play the music.
The Kahoot music.
No, the quizzes music. My favorite. Okay, give me a second. Sorry guys. Are we? Yeah. Are we gonna do anything for the winners? Sweets. Headpads from you. Huh?
What?
What? Okay guys, if you get full mark right for the quiz, we'll give you some sweets. We don't have that, I'm sorry.
Shikai, you better pray that not that many people can do box.
Where's Kim Yong-ju?
Kim Jong-un is the other person. He's teaching the best people maths.
How come we suddenly have nothing left?
Because everyone go eat, right?
It cannot be this is not true.
Oh!
What happened to sleep though?
Huh? Wait.
I think you need to go 7 last.
My bad. Give me a second. Can we blank the screen?
Like okay.
So I will.
Where is my...
I'm going to distribute that.
Wait. Okay. Alright. Where is my sound? Okay, I'll start when everybody's in. Huh?
I've delivered the candies because they wanted. Okay.
What do you take? We need to give them.
Can you just give them other ones? Give them next CC session. For time to prepare also.
Sure.
Yeah.
Where my music go? That's my quizzes.
Wait.
Huh?
I can press that. You can remove people.
Wait, is this for the?
Please do not remove people. Okay. Don't remove other people. That's not very nice.
I don't want to remove people.
Yeah, don't.
Who is Sims?
Simple, yeah.
Oh, cannot. Inappropriate name. Remove. Come up with something better.
What happened if I remove Shikai?
That was me! wait, what's the code again?
Wait, I can remove Shikai.
Please don't.
Can you do it?
I didn't do it. How did you type a triangle? Who typed a triangle?
Oh, it's inside the math thing.
Oh.
Wait, is everybody in? What is this?
Why is it two stars?
Okay, I start.
Okay.
No objections, alright.
I believe in you.
Wait, I shouldn't be showing you guys
It
this.
doesn't show access.
Wait, you have to do it from your own phone. Yeah. Okay, easy. Fumak.
Oh my god, why is it so slow?
Sit to the right. The blue table. Or like that way.
Why is it no for wrong answer? It's the same thing.
There's only one answer. That's very informal answer.
No, we're reserving for the
Why is my name one of the options?
How about in ninth place? I'm stupid.
What are the 4 assumptions you make in thermal physics?
Dave.
Duration of collisions?
I don't know.
Elastic collisions?
Yeah, yes.
Net?
Fuck, I got my own question.
Bro!
Why is
I don't know. It's not even spelled right.
Why is false and no and
legit.
and no is wrong, but false is correct?
Oh, that one right. It's a certain type of issue. It's called a skill issue.
Oh, Huh? Oh, I got double point.
Why is Steve no wrong?
Skill issue.
Maybe still they made the same thing. They said no, they said what is this? Okay, they said like some statement that I said no. And another false. No, it's not false. Oh, I don't know. False didn't even make grammar.
Wait. That's crazy.
Let's use it.
I can teach them basics.
Oh wait, my Wi-Fi died. Why does my Wi-Fi can't die?
I can teach them basic C++.
Okay.
But we want to video computer. If you want, we can also early dismiss them.
Okay. See first.
Wait, Esther, can I see the number? I wasted my power on a question I got wrong. Yeah, I wasted the question I got wrong. Okay, now I see. Why am I 0 points on my own phone, bro? My 14th, man. I just 15. What's the goal? I don't know.
I won't give myself. Just testing. Right.
Yeah, bro, can I see the code, bro? That's the code.
Are you gonna rejoin again?
That's the code.
No, let me just end the game. Oh, my Wi-Fi is dying, man. God damn it.
What's the average timing rating? Wait.
As long as you're not scared, right? You just face the challenge head on, you should be fine.
For what?
No, but I don't study anything. It's too fast. So like overall, no, my point is the confidence.
Okay, Okay, you know what? You know what? Wait, Esther, can I have your phone? Okay guys, I think I'll just wrap up the quiz here. So I'll just give switch to the top 5. So
number 1 is Sugar. That's great. You guys are doing it. So we're giving switch to the top 5 now. Number 1 is Sugar. Number 2 is 23 S560 Ashi. Oh, that's you!
I'm kidding.
Okay, 3, 1 is Pink Queen. Next one is shit. Oh, it's you?
I don't know what can be.
It's not good.
Okay.
Wait, how do I go down?
Well, I think no, that's my favorite.
Who's that? Yes, it was right.
Yeah, one is
You Bro, Sugar is so good. Already 0 out of 16, bro.
Okay guys, thanks for doing my quiz.
Yeah, I think so too.
I
won the game.
Open it.
Skill issue.
Bro got 2 random blocks. Bro, he has a thing. Twins, bro. He's got twins. Open the damn thing. Let me go get a glass. You should do something else.
Your turn.
My turn. Okay, my turn. I'm just going to check if I've been replied to.
Congratulations. It's a girl and a homosexual. Okay, now I have a video of you saying that. Start to lead slowly.
Okay. By the way, your Wi-Fi is dying. Really?
So like, that's not
Yeah, I'll give you back.
It's okay, I got
Yes.
this. Okay, so I'll do my masterclass.
Plug it in. Lock in.
Lock in, guys, lock in. Lock in. Ah, shit, I've been OBSing this whole thing. By the way, I've OBS the whole thing. Okay, good.